Hello everyone, welcome back. Myself Rahul. So today we are going to solve a problem related to arrays. Problem name is first missing positive. Let's go through the problem. Given an unsorted integer array nums, return the smallest missing positive integer. You must implement an algorithm that runs in on time and uses constant extra space. So we are given an unsorted integer array and we have to return the smallest missing positive integer. So here the input is 1, 2 and 0. So the smallest missing positive integer over here is 3. In this example 3, 4, minus 1 and 1. So the smallest positive integer over here is 1. 1 is present, then comes 2. 2 is not present in this array, so the answer is 2. Right, so it's a very easy problem. Let's see what are the possible approaches to this particular problem. So let's take an example of let me just write a example over here. Example can be anything, like let's take some set of positive integers as well. 5, 2, 1, minus 3, 6, maybe 8, right? So what is the answer we have to return over here? So this is the array that has been given to us. So by first missing positive, it means we have to return the smallest positive integer that is not present in this particular given array. Positive integer starts from 1. So what we have to do is we have to check, like one of the approaches can be like we start with the number 1 and we check whether 1 is present in the input array or not. Right? Then if it is present, then we go to 2. If it is not present, then 2 is the answer. Otherwise we go to 3. 3 is also present in this array. Then comes 4. 4, we search for this 4 in this array. 4 is not present, which means 4 is the answer, right? And one more thing is, if the size of the array is n, so we can be pretty much sure that we have to do this searching thing n number of times only, right? So we have to start from 1 till maximum point of n, actually n plus 1, right? So the time complexity for this approach would be like we have to search for all integers from 1 to n, and for a particular integer to be searched in a given array, that time can take further n. So the time complexity would be of n into of n, it would be n square, right? So second approach to this problem can be what if we somehow sort this array. So after sorting, the searching actually becomes quite simpler. So after sorting, the array would become minus 3, 1, 2, 3 is not present, 5, 6 and 8, right? So this is after sorting the array. Now we just need to do a single pass over this uh, array, and we can just basically return whatever first positive element is missing. So minus 3 is not a positive element, we can ignore it. Then comes 1, right? So 1 is present, then comes 2, 2 is present. Then we search for 3, 3 is not present because we had encountered 5 after 2, which means 3 is our answer, right? So in this case, the sorting would take of log n time and the searching would take a maximum of n time, so the time complexity would be n log n, right? The third approach to this problem can be um, if we somehow use set over here, right? So what we can do is we can iterate over this input array, and whenever we encounter a positive element, we can put that element into a set. So we encounter 5 first, we put that into a set. Set is nothing but a hash table. So 5 we have put into the set, then comes 2, then 1. Minus 3 is not a positive element, so we don't put it into a set. Then comes 6, we put into a set. Then comes 8, then we insert 8 into the set, to the hash table, right? And also one more thing to consider is, like, searching for a particular element in a set takes on an average basis of 1 time, because it is implemented on the basis of a hash table, right? So we again follow the same process that we had taken in the brute force method. Like we will search with the smallest positive element, which is 1. So we search 1 over here, we are able to find it. So here the searching is actually taking of 1 time, but in the brute force method, searching 1 in the input array was taking of n time more, right? So now we search 2 over here, we are able to find that in 1 time only. Similarly, we try to search 3 over here in the set, but we are not able to find it, which means 3 is the answer in our case. What is the time complexity over here? Time complexity for this is of n only, because first we need to create a set which takes of n time, and then we need to search individual positive elements into the set, which would also take O of n time. So O of n plus O of n would be O of n only. Space complexity also, here it is also of O of n, because we are creating an extra set. Can we somehow reduce this time complexity or space complexity? So in the problem it is mentioned that you must implement an algorithm that runs in O(n) time and uses constant extra space, right? Because this is a hard level problem, so there are some similar questions in which some easy level problems are mentioned over here, which are somewhat variation of this problem, right? So in this problem which we are considering, the array can have the positive and negative numbers both, but this problem called missing number, the array could have only the positive numbers. So I would recommend you to first solve this problem, and you would be much like it, you would find much easier to solve this problem after that, right? So coming back to this problem again, uh, yeah. So so the only issue that we have with us is that, like, we need to handle the negative numbers as well in this, right? So can we somehow get rid of the negative numbers from the array and just consider positive elements? Yes, we can. Like, one of the methods can be, like, given an array, we can segregate the positive elements and negative elements in two parts in the same array, right? So let's using some for loop, somehow we have segregated the positive elements over the first half and negative elements to the second half, right? So we can completely ignore the second half of the array and just focus on the positive elements. So this is actually a new array in itself, which just consists of the positive elements. So let me just write what, let's take an example: 5, 2, 1, 6, and 7. Let's see, let's suppose like this is the positive array that we have created in the end, right? So how are we going to find answer over here? One careful observation is, like, let me mark the indices as well. One observation over here is that our would always lie would lie between n plus 1, would always be less than n plus 1 if n is the size of the array. Why is that case? Like, if n is the size of the array, right? So what are the maximum positive integer we can reach, right? If we start from 1 and all elements are unique, 1, 2, 3, 4, 5, right? Like this, and this n, right? So this is the maximum uh, positive element that we can reach in the answer. Like, basically the answer would be, in this case, would be greater than n, which is n plus 1, because if any of the positive elements is missing from this array, then that would become the answer in itself, right? So instead of this array, the array was 1, 3, 4, 5 till n, right? So in this case we are missing 2 over here, so 2 would become as the answer, right? So if all the elements are present from 1 to n in the same array, then answer would be n plus 1, right? So we can be rest assured that our answer would always be less than equal to n plus 1, right? And also one more thing to consider is, like, we have to note that our, can we somehow use the same array in itself to maintain that this particular element has been visited? The answer is yes, because the answer is going to lie between 0 to n, 1 to n plus 1, right? And our indices range is also between 0 to n minus 1, right? So can we use the indices to maintain whether a particular element has been visited or not? Yes. So let's start iterating over this array. So at the first index we encounter 5. So what I'm going to do over here is I'm going to use this same array to maintain that we have visited 5. How I am going to do that? So whatever value is present at a particular index, here it is 5, I'm going to decrement 1 to it. The value is 4. So I will go to this particular index and mark the value as negative. Why I'm doing this is, like, a negative value is telling me that this particular index has been visited, right? So suppose now I go to this 2, right? So it would be 2 minus 1, which is 1. So I need to go to the first index and mark the element as negative. So I'm marking this 2 as minus 2, which tells me that this particular index has been visited. Now I come to this one, so it would be 1 minus 1, which is 0. So I go to the 0th index and mark the element as negative, which is minus 5. Now I go to this 6. So 6 minus 1, it is 5. It is greater than the size of the array. So I don't need to mark the element in the... So basically I can't mark it as negative because it is exceeding the length of the array. Right, so now I come to this 7. It is 7. I'm taking the absolute value. So minus 7 absolute value has been taken. Minus 1, it is 6. So 6 is greater than the size of the array. So I can't mark anything as negative. Right, so whenever, like, after iterating over the array, what I need to do now is I need to do one more iteration of this array and see which element is positive. Right, so here this element is coming as positive. Like, I go to this index minus 5, it is negative, minus 2, this is negative. Now I come to this one, it is positive, which means this index, this 2, is has not been visited yet. Right, so what I'm going to do is, the answer in this case would be the index which I'm at plus 1. So this is the index which I am currently at, right? And I'm going to increment 1 to it, which would give me 3. So 3 is the answer, which means 3 is the positive integer which I have not visited till now. Right, so basically here I am using the indices of the given array and basically marking the elements at a particular index as negative. And negative element is basically denoting me that that particular element or index has been visited. So these particular indexes has been visited, 0, 1 and 4, but these two particular indices 2 and 3 has not been visited, right? So whenever I do the second pass over the input array, whatever the positive value, the first positive value I encounter is going to tell me what is the first missing positive value with us. Right, so I have already written the code for this problem. Let me try to explain the logic. So as I explained earlier, like, first we need to segregate the input array into positive and negative elements, right? So that's what is being done over here. Like, I'm maintaining one variable called j, and I'm incrementing j only if the value present at an index is positive, right? So after completion of the single iteration, whatever the value of j is, let me try to explain it. We do it using this example only. So I is over here and j is also over here. So if this value is positive, I'm going to put if this value is positive, I'm going to put whatever value is present at the ith index in the jth index as well. So 5 would be placed at this index only, no worries. Then I go to 2, 2 is placed at the jth only. Then I go to this one, then I go to minus 3, right? It's a negative, so j was actually over here, sorry, over here, and I would reach over here. Then this value is positive, then I would place whatever value is present at ith index to the jth index. So this minus 3 would be replaced by 6. Then I would reach over here, and j value would also incremented from here to here, and 8 value would be populated over here, right? So I need to just consider this part of the array. I can ignore this 8. I can ignore this 8. Right, so this is what is being done by this for loop. Right, so j, whatever value is present in the j, I have to just consider that part of the sub array. Right, so I am updating this n value to the whatever value j had, and I'm running a loop till the nth value. Right, so after that I am doing this logic. So uh, this is like I'm taking the absolute value, whatever is present at a particular index I, and if that value is less than is equal to n. Right, so in this case I can see that the 6, whenever I had encountered values 6 and 7, I was not able to update those values in the input array because those values were greater than n, for n here is 5. Correct, so I'm checking whether the value is less than n. Only in those cases I would be able to update the array indices. Right, so I'm basically taking one value less whatever was present at a particular index, and I'm checking if the value is already positive. Right, only in those cases I need to mark it as negative, because the one of the cases can be, let's see, 5 2 1 1 6 7. Suppose this was the array. Right, index is 0 1 2 3 4 5. So 5 comes here, so we have to go to the fourth index, mark it as -6. Now I encounter 2, I subtract 1 from it. 2 minus 1 is 1. I go to the first index, which is 2 itself. I mark it as -2. Then I come at this particular index 1, so 1 minus 1 is 0. So I go to the 0th index, mark it as -5. Then I again encounter 1. Right, so 1 minus 1 is 0, so again go to the 0th index, but the value was already negative over here. So that's what I am checking over here. If the value is positive, only in those cases I need to mark them as negative. Otherwise the value is already negative, which means it has been visited already. Right, so after this for loop has been completed, I'm doing another pass in this input array, and whatever the positive value I encounter, in this case the positive value was 1, this one. Right, if it is a positive value, I just increment 1 to it and return that value, return I plus 1. And if all the values were supposed negative, so what can that case be? Let's try to think that 5 4 3 2 1. Suppose this is an example. In this case actually we go 0 1 2 3 4. So this value is negative, then I go to the fourth value, it becomes this negative, this negative, this negative, this negative. Basically all values would turn to negative using this for loop, this for loop. Right, and when I'm doing a secondary pass over this input array, I could not find any positive value. Right, in those cases what I'm going to do is I need to just return n plus 1. N is the length of the array. Length of the array here is 5. Right, so I just need to return n plus 1. 5 plus 1 would be 6. That's what I'm doing over here, just to handle one of the edge cases. Let's try to run this code. Yeah, it's okay. I'm submitting it. Yeah, so runtime and memory usage are also perfectly fine. So for this problem, we had considered all the possible approaches, from the brute force method. Then we thought of sorting, and then we thought of using a hash map in which we were saving time, but we had to use some extra space. Then we somehow used the existing array as a space in itself and modified the input array to mark them as visited and not visited. Right, the negative value is basically denoting that the particular index has been visited. Right, so we didn't require any extra space. So that was a very, like, basically an easy problem, I would say, in which we had used the input array itself as an extra space. And it's a very famous problem that has been usually asked in the interviews. So try to analyze this problem and see what are the other ways in which we can solve this. And I would recommend you to go through the similar questions as well, because they are very much related and use the same technique, like in which we have to use the same array itself to mark the elements as visited and not visited. right? So keep on practicing the problems, and I will see you next time with another problem of LeetCode. Thank you, everyone.